Welcome to Learning with UNP. In this session of Python for Data Science, we are going to understand about Lambda function. That includes what is a Lambda function, what are the advantages of Lambda function, and finally, working with Lambda function. Let's begin with understanding about lambda function. A lambda function in Python is a small anonymous function that is defined using the lambda keyword. Unlike regular functions that are defined using the def keyword, lambda functions do not have a name. They are often used for short, simple operations that are intended to be used only once or few times. A lambda function can take any number of arguments but can only have one expression. Let's now look at the advantages of lambda function. First comes conciseness. They allow you to write small functions in single line of code, which makes your code more compact and readable for simple operations and tasks. Second comes anonymous. They are unnamed functions, allowing you to use whenever a function is needed without formally defining a new function. Third comes functional programming. They are often used in higher order functions. Higher order functions are functions that take other functions as arguments, enhancing the functional programming style in Python. Here is the syntax of lambda function. Lambda arguments colon expression. Let me tell you what each component means. Lambda. This keyword is used to create a lambda function. Arguments. This is a comma separated list of arguments that the function takes. Expressions. This is a single expression that is evaluated and returned by the function. Now, let's understand about lambda functions with multiple arguments. A lambda function can take multiple arguments just like other regular functions. These arguments are listed in the same way, separated by commas. The expression can use all of these arguments listed below. First one is no arguments, lambda expression. It defines a lambda function with no arguments. Second one is one argument, lambda x expression. It defines a lambda function with one argument x. Third one is two arguments, lambda x comma y expression. It defines a lambda function with two arguments x and y. Fourth one is multiple arguments, lambda xyz so on expression. It defines a lambda function with multiple arguments such as x, y, z, and so on. Now let's look at evaluating the expression. The expression in a lambda function is evaluated and returned when the function is called. The expression must be single, simple, and cannot be a complex block of code. This keeps lambda functions concise and focused on a specific task. Let's move on to checking the common misunderstandings dealt with lambda function. First one involves complexity. Lambda functions are not suitable for complex operations and should be used for simple short-term tasks. Second one involves readability. Overuse of lambda functions can reduce code readability. We must use them judiciously to enhance clarity and conciseness. An important point to be noted here is lambda functions provide a quick and easy way to define small throwaway functions without the overhead of a full def function definition. They are an essential part of Python's toolkit for functional programming and concise code reading. Let's look at the pseudocode representation of it. Step 1. Use the lambda keyword to define a lambda function. Means start by using the lambda keyword to define a lambda function. Step 2. Specify the arguments followed by a colon. Means list the arguments after lambda. Step 3. Write the expression that the lambda function will evaluate and return. Means after the colon, write the expression that the lambda function will evaluate and return. Step 4. Call the lambda function with arguments as needed. Means use the lambda function by calling it with the necessary arguments. Let's now look at various examples demonstrating lambda functions. The first example involves lambda with single argument. we define a lambda function named square that takes a single argument x. This function squares the input x using the expression x double star 2. When we call square of 5, it computes 5 double star 2 resulting in 25, which means the square of 5. 5 into 5. Let's execute this and check. As we discussed, square of 5. 5 into 5 is 25. Now let's move on to second example. The second example involves lambda with multiple arguments. We define a lambda function named divide that takes two arguments x and y. When the function is called with divide 123, it divides 100 by 23 and returns the result. Let's execute this and check. As we discussed, 123 after dividing gives this result. Now, the third example also involves lambda with multiple arguments. We define a lambda function named multiply 5 numbers that takes 5 arguments a, b, c, d, and e. When the function is called with multiply 5 numbers 12, 32, 48, 51, 60, it multiplies all the number together and return the result. Let's execute this and check. So the output of 12 into 32 into 48 into 51 into 60 is this. Finally, the last example involves lambda within a function, diff statement. We define a function called operate that takes three arguments, operation A and B. The operation parameter is expected to be a function. Inside the operate function, we call the operation function with arguments a and b and return the result. This allows us to use any function as the operation argument, including lambda function. We use operate function which is defined above with the lambda function as the operation argument. The lambda function raises the first argument x, which is 20, to the power of the second argument y, which is 32. The operate function then executes the lambda functions with arguments 20 and 32, resulting in 20 raised to the power of 32. Let's execute this and check. Finally, the result of this operation is printed, which is a very large number representing 20 raised to the power of 32. Here also we are using the operate function defined above with lambda function as operation argument. The lambda function compares two arguments x and y, returning the greater value. The operate function then executes the lambda function with arguments 10, 72, returning the maximum value between them. Finally, the result of this operation is printed with the print statement. Let's execute this. The output is 72 because among 10 and 72, the greater number is 72. This is all about today's lecture. See you in the next lecture. Thank you.